Hello, my name is Seth Polson, and I'm going to be presenting our work, Insights from Student Solutions to SQL Homework Problems. To motivate our study, I want to start by asking a question. Who uses SQL? When I was working in industry, I was surprised to find out that it wasn't just business analysts, data scientists, and software engineers that were using SQL, but I found that there was so many people in various job roles that needed to understand and use SQL to perform well in their job and to be able to make data-driven decisions. I assembled just a short list here of some examples. The list goes on and on. An analysis of Indeed job postings actually showed that there were more job postings asking for SQL skills than any other programming language. So in some ways, you could say it's the most in-demand programming language. And so this really provides motivation for our study and why we should be doing research and how to do a better job teaching people how to write SQL and query databases. To start out, I want to give you guys a little demo of PrairieLearn, which is the online homework system that we use at the University of Illinois so that you guys can see where our data is coming from. As a student in the databases class, I'll open my browser to PrairieLearn, and this is what I'll see. First, a description of the tables which my query will be run against. Then, a question prompt. Finally, there's a place for me to write my query. When I'm done writing my query, I'll click here, Save and Grade, and the output of the database engine will be shown below. Okay, now that you guys have seen PrairieLearn and what the student experience is like in our databases class, we can move on to our result categorization. So each student submission was categorized as either a syntactic error, a semantic error, or a correct submission. A syntactic error is where the database engine wasn't able to run the query for some reason, and it produces an error message and an error code. A semantic error is when the database engine is able to run the query, but the result set that the query produces is not equal to the expected result set. A correct submission is when the SQL engine runs the query and the result set does match the expected output. First, we started out by focusing on syntactic errors because it's easiest to analyze them given that there's provided error codes and error messages. There's also many interesting student behaviors we could see in semantic errors. For example, what kind of logical misconceptions do students have? Even correct submissions have lots of information in them that we could use to understand students better, like are they using features that they shouldn't have to use, or are they writing inefficient queries? But for semantic errors and correct submissions, it's much harder to learn these things. You kind of have to end up looking through a lot of submissions by hand. So we started out just by diving deeper on syntactic errors. So our research questions are, what are the distributions of submissions resulting in syntactic errors, semantic errors, and correct submissions in solving SQL homework problems? And how do they vary between question concepts? And what types of syntactic errors are made by students who are successful or unsuccessful when solving SQL homework problems? Just to give a bit of background to give a backdrop for our work, back in the 80s when SQL first came out, a few groups of people did user studies on SQL and other query languages and found that queries involving group by and correlated subqueries were some of the harder queries to write. More recently, a few groups have done an empirical analysis, like us, of student submissions and found very similar results, that students really struggle with group by and correlated subqueries. Another finding of previous studies is that syntax errors are very common for students to make, but they're kind of always overcome. Whenever students run into syntax errors, they said they were able to overcome them. One of the things that differentiates our study from previous studies is that we cover a broader range of topics. The databases course at the University of Illinois covers more advanced topics than the classes that were studied in these past studies. And so we're able to also provide data on the mistakes students make while solving problems involving triggers, stored procedures, and functions. The results of our study was that we first replicated the prior results and found that students do indeed really struggle with group by at the University of Illinois as well. And they also really struggle with correlated subqueries. The final result that we had from our study that actually broke away from the results from previous studies is that sometimes students never get past syntax errors. They'll be working on a problem, they'll have a syntax error and another and another. And when they give up, they're still stuck on a syntax error. And this wasn't seen by any of the prior studies. And we found that this especially happened on the more complex queries, like the triggers and the stored procedures. So this is one of the really big highlights of our study, is that on more complex SQL queries, students sometimes never get past syntax errors. Unfortunately, there are some limitations to our work. For example, we really just look at the submissions as a single entity. We don't treat them as sequences of submissions. We also don't have any insight into the actual thought processes of the students as they were solving these problems. We also lack understanding about how people use SQL in the workplace versus how they use it in their databases course. For example, in the databases course, they're working on these small examples, but are the struggles that they're facing the same struggles that people who are learning SQL on the job face when they're working on these big corporate data sets? We don't know. So there's a huge amount of future work that could be done in studying SQL education. For example, we could analyze the submissions as sequences. So back in 2006, Matthew Jaded proposed this error quotient, which tries to quantify how hard it is for students to overcome certain types of errors while programming in Java. But I think we could apply a similar idea to analyzing SQL submission sequences. We'd also love to create improved tooling for teaching and learning SQL, such as an instructor dashboard where they can see what the most common errors their students are making are in real time during a class, or an intelligent tutor to help students understand and get past the whatever mistakes they're making. We'd also love to have interviews with students to understand why certain things are difficult and other things aren't in SQL, where we bring a student in and have them talk aloud while they solve some problems. Another huge area for future work in database education is other databases. Graph databases like Neo4j and document-based databases like MongoDB are becoming more and more common in industry, and they're starting to show up in databases classes in universities as well. So this is something we're actually already starting to do, is analyzing submissions to homework problems where students were writing Neo4j and MongoDB queries. Thanks to everyone for watching, and I hope you enjoy reading our paper and keep an eye out for our future work.